The diagram shows two loudspeakers connected to the same signal generator. As the microphone is moved along the path XY, series of maximum and minimum sound levels is detected. Which of the following actions on its own will increase the separation between the maximum and minimum sound levels? So, since two signals arise from the same signal generator, they will be coherent, and hence we will observe an interference pattern. And we know the next formula. The general formula is that if you consider some point, and then this distance is L1, this is L2, so L1 minus L2, absolute value is called path difference. And when this path difference is equal to integer number of wavelengths, hence at this point there will be maximum. And when this path difference is equal to n minus a half or plus a half lambda, there will be at some point there will be minimum. And also we know an approximated formula when this distance from the sources to the screen is much greater than distance between sources. We can use the next formula, that distance between two consecutive maxima or minima is equal to wavelength distance to the screen divided by distance between the sources. And this formula works for the light, for double slit interference pattern, but here it's about sound, and this formula actually doesn't work. And if you need to calculate something, you cannot use this formula if it is not given clearly that distance to the screen is much greater than distance between two sources. But to answer about increase decrease, we can use this formula, and it works because it's quite different. And what do we need actually? We need the distance between maximum and minimum, and we can consider, for example, central maximum and the first minimum. And for the first minimum, path difference is just lambda over 2, but path difference is difference of these two lengths, and it's quite difficult to analyze these two distances. But if we try to use these, and we can assume that the distance to the screen is much greater than distance between two sources, and we need and actually as it's distance between two consecutive maxima or minima, and distance between maximum and minimum, it will be just a half of this value, and it will be directly proportional to lambda, distance to the screen, and inversely proportional to the distance between sources. And we need increase, so we need this to increase. And you can see moving the speakers closer, it means this, capital D decreases. It's not true. B, increasing the separation. If you increase this, you can see that S decreases. We need S to increase. C, increasing the amplitude. You can see it is independent of amplitude. Amplitude, it's about energy. Amplitude squared, it's proportional. Energy is proportional to amplitude squared. And the decrease in the frequency. And you know that wave speed, COV, is equal to lambda times frequency, and it's about sound, and speed of sound depends on medium, and it's constant here, so it's constant. And if you decrease frequency, you can see that lambda increases. So if lambda increases, this value which is required is also increases as required, so D is correct. And that's all for this question.